I'm Peter Eisentraut, longtime Postgres contributor. I'm with Second Quadrant. We have a sponsor table out there, so please say hi. My talk is with a title that a lot of people have asked me about beforehand. So opinionated is not always a nice word, but I'm using it in a technical sense that you might have heard of people talking about opinionated frameworks. For example, Ruby on Rails is sometimes talked about as an opinionated framework. And what that means is that someone has sort of made decisions for you based on their opinions and sort of designed things in a certain way so that if you follow their ideas, then you'll be more successful. And if you can do it differently, but then you might not be so successful. And so the idea behind this talk is also that there's many guides to Postgres replication out there, and Postgres documentation, and blog posts and tutorials and other talks that have been given at previous conferences. And a lot of them go like, well, there's all these options, and you can do this and this and this, and then based on some requirements, you can do this and this and this and this. And so at the end of the talk, you go out with 48 different options of what you can do, and you have learned a lot, but you can't really go home and go to work. So what I want to do here is based on my opinions and my experience to give you a guide of what I think works and leave you with not too many decisions to make on your own. So that is what this is going to be. So this is going to be just a sequence of, the scenario is basically you have nothing, and somebody tells you got to set up a Postgres cluster, and how would you go step by step to set that up and have it, with the highest chance of success at the end. So let's go through that. So the first thing you want to decide or extract requirements from whoever tells you to do this. Why do you need to replicate? And if you sort of narrow it down, there's about two reasons why you might want to do this. And one is that you want to increase performance by adding more hosts that can share the load. And the other is that you want to make your whole setup more reliable by adding additional hosts that can take over if something fails, right? So those are the basic two requirements, two reasons that you might have. And it's good to think about which one you have. Maybe it's both. And that's also a perfectly legitimate and useful scenario, but even if it's both, they should still be implemented separately. For example, if you just have a master node and you set up a slave and say, well, this is going to be my read-only slave node for performance, but it's also the standby in case the master fails, then that's not really a good setup, because then if you actually do need to fail over, you only have then half the performance, and then you have lost your performance characteristics of your application. So you got to think about which one of those you want to implement, and if it's both, you should implement both of them separately. Right? So in terms of hardware, I don't really have specific recommendations. Just there's traditionally databases were set up on big bare metal. Virtual machines are now also in use. There's sponsors out there obviously that are trying to sell you on this. Just get the biggest stuff you can get within reason. The one takeaway here is just know if you need more where to get it. Right, because if you do want to scale and you set up your 8 nodes or whatever, and then it turns out your application is growing, you need more. Like, where are you going to get the 9th and the 10th from? Do you still know how to get the same hardware? Can you still get that? If something fails, can you get replacements? Do you have a warranty? Those kind of things you got to think about. Or actually, yesterday I just learned if you have a cloud provider, then there might be a limit of how many things you can actually provision. So if you had that limit and you need more, can you even get that? Just clarify that, right? This might be outside of your control because the data center or whatever is already set up, but just do a sanity check of what you're dealing with. Don't worry about IP addresses too much. Don't try to remember them. We'll talk about in a moment of how to get around that. Some people have multiple networks. They have different networks are firewalled in different ways. There's maybe you have a separate production network and a management network, or even a separate replication network. It's possible. Don't make it too complicated, but just understand what your existing setup is. Make sure your DNS is sane. Make sure that forward and the reverse DNS match. If maybe a host has previously failed and was recycled, the name was changed, but the reverse DNS was not set up correctly, that can just totally drive you crazy. So just have sort of a checklist for yourself in place so you know what these things are. Operating system recommendation. Obviously, there's many different fine operating systems, but if you want to not be an outlier and have to try to figure out everything by yourself, I recommend one of these. And if you stick to one of these, you will have best community support. Community will provide you with updated packages. The operating systems themselves will come with reasonable packages pre-installed. You will, if you need any kind of professional help at some point, you will have the most reasonable chance of someone actually supporting these. So these are good choices, right? And the difference between, there's some taste at the end, right? Why would you want to choose Debian Ubuntu versus Red Hat-based operating system? So that's a matter of taste, and we don't need to talk about that here. If you do choose Ubuntu, pick a long-term support version. And if you want to pay, or if usually the difference between the Red Hat Enterprise Linux and the CentOS, they're kind of the same, right? But you pay for one of them. Just think again. If you need provision extra hosts, can you get more licenses quickly enough? Or if not, then you can't really scale that way, right? If you sort of a long-term recommendation, perhaps more than something you need to learn about immediately, consider learning a little bit about how systemd works. Because if you are going to set up a replication cluster, you're going to be starting and stopping services a bit in certain orders, and you want to make sure you know how that works in modern or upcoming operating systems. So if you're using any of these versions, then just consider reading up a little bit of how systemd works and how it's all wired together, because it can be very confusing if you're just sort of thinking in terms of the old System 5 init systems or Upstart perhaps that you've used. If you start services in the wrong way and systemd thinks it's not started yet, it might kill it again, and these kind of things can happen. So it just, if this is something maybe to learn about in the near future. There was a small conference we had in Philadelphia a while ago where Robert Tree, is Robert here? No. But he's running around out there. He said he had a good sort of phrase that DBAs are the original DevOps, which I like, because you always have to do a little bit of ops and a little bit of development. And so I think as DBAs, we should also embrace configuration management systems, because the premise of this undertaking is that you're going to be setting up a whole bunch of database servers that are supposed to talk to each other. And ideally, they're all set up sort of in an automatic way and kind of in a similar way. So think about how you achieve that. Do you just do it manually and hope it works? Do you have a handwritten checklist of how that works? Do you have probably have maybe a shell script set up that does that? But there's problems with that, because then if you later make configuration changes, how do you push them all out to the same places? So if really recommendation, learn about using configuration management systems. One of these, they all get the job done. There's lots of opinions on which one of these is more suitable in one way or the other. But if you're not at all using anything like this, it's just going to be much harder, right? If you want to do Postgres replication, please use Postgres 9.4 or later. If you're using any older versions, you just let them run. But if you're setting up something new, please use Postgres 9.4 or later. That has to do mainly with, for purposes of replication, the replication slots feature, and Also, a feature in Postgres 9.3 that is useful allows, which is called allow standbys to follow timeline changes on the master. What that basically means is if you change the master, all the remaining slaves can follow the new master. That is super important. So if you install an operating system, the operating system comes with Postgres 9.2, don't use that. Please just get a newer version. Postgres 9.5 is also fine, but it doesn't really buy you major things in terms of replication. Installation, use existing packages, they're fine. Don't invent your own stuff. Anything you get from these mentioned operating systems, use just whatever you install with your tool. There's a talk later today that I don't know yet because it hasn't been given yet, but that is going to talk presumably more about how to do that. And again, if you stick with the operating systems that I recommended, if you go, there are community-provided packages above what the operating system itself provides. So you get newer versions, more plugins from these sites. So just stick with that. And if there's anything missing that you think is not working the way you should, get in touch with the community and we'll probably add it. And use your configuration management system, if you hopefully have one, to manage configuration details. So if you need to, at any point, log in and manually change a configuration file, you have probably not done this correctly. So before you set up a bunch of things, it's good to kind of know the terminology. And this, you can make up your own terminology, but just have one. So you and your colleagues and your documentation that you hopefully write know what you're talking about. So note that at no point here do I talk about a cluster, because a cluster has about 8 different meanings in Postgres, so don't do that. And the terminology I recommend is very simple. A host is a machine that you run an operating system on. An instance is a one running Postgres instance. And if you have multiple that are connected by a replication, then I call that a replication group, or sometimes I call it an instance group. And in Postgres, you have the Postgres documentation does not use the terms master and slave. They talk about primary and standby. I don't like the term standby so much because it kind of implies it's a failover target. But if you have nodes about for just scaling out, they're not really standing by. They're actually doing work. So I like the term secondary for those. And the term spare I use for a host that is currently not doing anything, but it's available for me if I need to set up a new instance somewhere. So it's always, especially if you're dealing with hardware, not with any virtual deployments, it's good to have a spare around. Because if one fails, you don't want to have to call your vendor and have it shipped. You want to have one available right away. So once you have the terminology, you got to think about naming things. And there used to be a time when it was cute to invent sort of bespoke names for every host. But I think that is not, first of all, it doesn't scale past like 8 hosts usually. But also, then people tend to kind of get attached to these names, and then when you do failover or something fails or you scale out, then the names don't match anymore what you had in your initial imagination, so I would not recommend it. Just numbers things. It's very easy. The first host you put in your data center is 1, and then the next one is 2, and the next one is 3. It doesn't matter. And those could be the host names. And then if you have, for replication groups, this is just one naming scheme. Just make sure the replication groups have a different naming scheme from your hosts, so that when you move things around, you don't have sort of confusing mismatches. And one thing you could do, for example, if you have the capabilities to change your local DNS, simply you can, whatever's the primary of a replication group, you can point a CNAME to that, for example, and then have your application talk to that. And then the actual instances inside the replication groups, there's, again, a sort of proposed naming scheme, and you can put that into the cluster name, which is the term cluster, which I don't like, but the cluster name is a configuration setting in Postgres 9.5, I believe it was added. So you can actually label your instance. Could have been named instance name, but the term cluster was already used in that case. And that's easy to sort of for logging, and your process list contains the instance name in that case. So it's nice if you think about this beforehand, because then later on, as you add more stuff, it's just very easy to know how things are wired together. So again, don't get attached to the names, though. A lot of places set up one database, and they call it DB1 maybe. And then, then maybe they have to move off that, because maybe they have to fix the hardware. So they set up another host, maybe it's DB2. Or worse, it's DB1 standby, and then you fail over, nothing matches anymore. So that's the first mistake. The second mistake is you fail over to DB2 maybe, and then you get upset. So, well, everything was already pointing to DB1, and now it's DB2. Should I change that? No, you should not change that. Just leave it. And then maybe you set up another standby, which for DB2 is going to be DB3. And then maybe a week later, DB1 is repaired because you get a spare part. And then you wonder, should I just move everything back to DB1 just to make it nice again? No, don't do that. So just don't even care about the names. Just use the next host. Because otherwise you spend all your time moving things around just to get the naming right, and that is not productive. So if you move things around, you got to have a way to route the connections to wherever it currently is. I recommend pgbouncer. And there's other options that you've probably heard of. pgpool is an option. Some people use HA proxy. Some people use virtual IP addresses. That's what we did in the 90s. Some people use DNS changing around. Those are all possible. I don't recommend them. They have a lot of problems. So pgbouncer is awesome. Just use that. Everything connects to pgbouncer. You can have logical names for all your stuff, and then the host and all the other connection parameters, just later you can just change them internally. None of your application code has to know about that. So pgbouncer should be in the picture if you do this. Basic configuration, there's just a list of stuff you should look at. There's other resources about how to configure Postgres. So these are just kind of the things that you ought to look at from my perspective. If you have a lot of hosts, or you're planning to have a lot of hosts with Postgres on them, and you plan to kind of move your active host around, then whenever there's an incident you want to investigate, you want to look at the log files, you're going to have to first figure out where the log file is, because it could be on this host or on that host, or maybe something failed over, and then half of the information is here, half of the information is there, or maybe you do read scaling based on some load balancing mechanism, then the information is all over the place. So that can be very confusing. So I recommend centralized logging with syslog. And our syslog, which is the implementation that I mentioned here, is standard now in all modern Linux distributions. So it has a lot of functionality and features that you can configure. So the one easy way to do it is just have another host with a lot of disk, and you dump everything to a file. Then you can find everything in one place. There's fancier solutions if you want to put some money to the problem. There's things like Splunk, for example, or Elk that collect the log streams and put them into some kind of other kind of full text search kind of database, and then you can run interesting things, reports and stuff off that. So that's a useful thing to look into at some point. But at least have some kind of mechanism in place to get the log files off the host, so that you don't lose information when you just the host gets decommissioned or destroyed, or you just shut it down if you're in a virtual environment. So get the logs off somewhere. Use a good logging configuration. Basically, turn all the logging on. So, and the log line prefix that I recommend there is to work with. A lot of people like to use something like that because it works with pgbadger. But other than that, you can make up your own, as long as you have, timestamp and PID and user and those kind of a lot of information in there. So here, this is now the interesting part. this is what you need to add to get replication going, and it's sort of an ongoing debate in the Postgres community. Why do we have to set 6 settings just to get replication going? It's annoying, but you have to do it. And so setting wall level to hot standby or replica is, as it has been renamed. That's just you turn it on and you don't have to worry about it. You need to think of how many secondaries you want to have on a node, so you have to set the replication slots and the wall centers to a number. When I initially wrote this a couple weeks ago, I put 8 here, and then quite immediately after that, I changed it to 16 because I figured 8 was not enough. And just actually a couple days ago, I changed it to 32 because I figured 16 that could also run out really quickly. So, and it's not super. I mean, don't put 1,000 in here, but it's not super expensive to have a couple more. And you want to have a lot of buffer here because you could have an issue where something fails, you need to set up new things. PG-based backup, which we'll talk about in a second, needs already 2 connections just to run a base backup. What could happen? Maybe PG-based backup gets interrupted. PG-based backup process dies, but the server hasn't quite noticed yet, so the connection kind of hangs open, and TCP internals will sort it out later. So the 2 connections are already blocked. You try it again. You already have used 4 connections just without even doing anything, right? And all the other stuff has to run. So that could be really bad if you run out of these connection slots. So just have a lot more. And then the hot standby and the hot standby feedback actually go on the secondary node. The master doesn't use that, but I like to kind of keep the configuration files the same everywhere. So I just put that in here. And the wall keep segments is kind of a workaround for an issue that PG-based backup, at least in released versions, does not know how to use replication slots, so you have to set that to some random high number to make sure the wall is not removed as PG-based backup is run, which is sort of a bug essentially, and it's been fixed, I think, in 9.6. So people put like random high numbers for wall keep segments. Don't use any of these. Just forget that these ever existed. If you're using replication slots, which I recommend, you don't really need that for reliability. If you do need an archive for your backups, you use PG receive xlog. But I would really recommend against using archive command for anything, because if you're doing that, you quite likely are doing it wrong in some way. It's really hard to get this correct, and you don't really need it anymore. So just forget that that existed. Then you need to set up hba.conf, and there's, it sort of depends on, I like to sort of give a sort of concrete advice, but this really depends on your local requirements. The super awesome solution obviously is use SSL for everything, but realistically, a lot of people don't do that. So password authentication is probably fine. Just make a separate user for replication, add the appropriate lines to hba.conf. So instead of the XXX, you would put probably MD5. And it's also okay to put passwords, replication passwords in PG pass. And then you need to figure out a way to get them there securely. So this is kind of a fiddly thing that's not kind of easily, elegantly done. So then when you have all this set up, this is where your naming comes back in. So if you have a name for everything figured out, this is easy. So you need to create a replication slot on the primary for your secondary. So this I recommend that you name the replication slots by the instance name. And this is a command that you run on the primary, but the instance name here is the secondary's instance name. So that basically this tells in sort of abstract terms that on the primary, just register the secondary node with that name. And then it kind of keeps the wall around. That's what it technically does. But this basically just registers the interest of the secondary in the primary. Then you run base backup, and lots of options here. And this could be simpler, but this is basically how you do it. So the C is for the checkpoints. The P is progress. The V is verbose. The D is the directory where you put it. And this you have to check with the operating system where the correct place for that is. and the host and the port, and then the user we just created. And then again, you put the slot in here. This only works with 9.6. Before that, there's no slot option, so you have to rely on the wall keep segments. And then the X stream, which maybe should also be the default, but so you have to remember all these options, so kind of make a script for that, possibly. And then you have to write a recovery.conf and all these things. Again, here, put the names in the right places. So again, this is the recovery.conf goes on the secondary. Here you use the secondary instance name, and you put it in 2 places. So one is for the slot, the replication slot, so that it knows, it gets the right wall. But it's also good to put it in the application name, so that on the master, you can, if you look at the list of connections, you see what it means. Yes, question.
Are those related to each other internally to Postgres in any way, or is that just for your own sanity later?
The question is, are these related to Postgres in any way, or is this just for my sanity? This is sort of both, really, and this is kind of the hard part, right? So the slot name is something that Postgres manages, the replication slots. And you can create any replication slot you want with any name and fetch wall traffic from it. My recommendation is you name the slots after the connecting instance. The application name is kind of only for reporting, because it shows up in the connection list, and then you know what is this connection. Otherwise, you just see, well, it would say wall receiver, just, that's a technical internal name. Just wall receivers connecting from this IP address. And then, okay, you can figure that out, but it's not really helpful. The application name has a sort of secondary use. If you use synchronous replication, it has to do with how you configure synchronous replication to pick whatever the next synchronous standby is. So it's also useful in that case. So it's sort of both for reporting or for your own sort of overview, but also has some internal meaning. And so if you make a mess out of this, everything gets really confusing. So you start the secondary, and here you need to know how your operating system works. So if you are using sort of an upstart or system 5 init, then it's probably the first line. If you're using system D, it's probably something like the second line. If you somehow, against all advice, somehow put it in yourself, you can use pgctl directly. But if, for example, your system is set up for system D and you use pgctl directly, it'll create a mess, so that is not good. So, and then you're good to go. So now you got to figure out how to monitor all that stuff. So there was a great talk just before the break, how to monitor things, and all that advice I can just support, and I recommend checking that out. So basically, just monitor all the usual things. And for replication monitoring, there's, again, this was already mentioned earlier, but there's sort of 2 ways you can do it, and they kind of go together in a way. So the first thing to monitor, I guess, is PG is in recovery. That actually checks, is the state of the server actually the one you expect? And this kind of seems silly, but it is sort of a sanity check for both your monitoring, if the monitoring is actually monitoring the right things, and also for your host's state. That if you think this is the primary and these are all secondaries, actually check that that's true. Otherwise, it can happen, and why these things happen, and who knows, but that randomly a standby host comes out of recovery and promotes itself for who knows why. Accidents, whatnot. So it's good to actually check that. pgstat replication is a table or a view that contains lots of useful information, so just read up on that. The canonical way nowadays to monitor replication lag is that query that the seconds lag, that one. So you subtract you run this on the standby, on the secondary, and you subtract the current timestamp from the timestamp that was last replicated, and then you set up a threshold depending on what you like. The problem with this, and this is well documented, is if your primary does not actually have any regular write traffic, the timestamp does not advance. So then you need to kind of figure out different ways, and what I actually do in that case, in the rare case that that happens, I have a cron job that runs on the primary, just writes something every minute or so. So you keep the timestamp moving. That's a hack you could do. You could also combine it with the byte lag, and the byte lag is more robust in that sense that it doesn't rely on any actual write traffic. You just compare the send location to what was received and replayed on the receiving side. And if nothing happens, that should be 0. But it's hard to kind of know what that number really means. Usually in terms of sort of a business requirements or an SLA, you think of like, I would like to have a lag of 10 seconds, 30 seconds, a couple minutes, 5 minutes, whatever you like. So that's easy to set up, but if the byte lag is some thousand number, that doesn't mean anything. So you would have to do sort of tracking over time, what is reasonable, and it becomes very complicated. So I usually don't do that if it's not necessary. It's nice to kind of just chart that so you can see it anyway, but it's not useful to set a threshold on unless you do a lot more digging. So switch over. So the terms that I think are now sort of fairly well established, at least sort of in these Postgres tools, is switch over versus failover. Switch over is something you do intentionally because you want to move your traffic somewhere else, maybe because you need to do some maintenance on the host you're switching away from. And a failover is something you do in an emergency if something has already failed. So those are the two different terms, and it's useful to kind of keep these clear and also in your internal usage and your internal documentation, perhaps, so you know what your intention is. So if you have done all this setup, then this is straightforward. You update your PG bouncer config to point to whatever new host, so all the traffic goes there. You stop your old host. Again, pick the right command, otherwise someone's going to get upset. And then you run pgctl promote, and then you have to, this is also something that's going to be improved hopefully soon, that the pgctl promote just tells it, the server, you go ahead and promote, and then the promotion actually takes some time possibly. So in order to do this robustly, you have to write a loop in maybe your shell script or whatever to wait until PG is in recovery is false. So it's true when it's a standby, and then once it's promoted, it becomes false. So you have to wait until that is happening. So I have a patch currently pending, which nobody has complained about yet, to add a wait option to pgctl promote so that is kind of folded together. And then a useful thing to do either at the end or even before is to prime the cache of the standby. Because if you just have a really busy host and you switch over to a host that hasn't done anything in weeks, perhaps, nothing's going to be in the kernel cache. So everything's going to be super slow for a long time. So it's, and a lot of people get away without this, but I just want to put this out there that it's useful to think about that. And this is sort of a hack. You just run vacuum maybe, just vacuum everything that touches everything a little bit. And there are fancier ways to do this, but they are platform dependent and complicated. So this is better than nothing. Just after you promote, just run a vacuum in the background, perhaps. So now, if you do this by hand, you can do this by hand, but there's a lot of things you can get wrong here, right? You have to log into. There's at least 3 different hosts you have to log into here, right? You log into your PG bouncer, do something. You have to log into your old primary, do something. You have to go into your new secondary, do something. There's a lot of things in the middle that can go wrong, right? You have to set up sudo in a certain way. You have to set up SSH maybe. You have to put keys. And then you have to kind of control this from somewhere. Right? You have to log into some box. Maybe it's your laptop or something that you actually have to orchestrate all these commands. So that can be risky if I had this situation where I had a script on my laptop. I could orchestrate all this great, but then at some point the laptop was not available, and then it was bad. Someone had to go back and do all this manually. So that's really bad. So do figure out a way to automate the heck out of this. that you have, some management host somewhere that has a script that everybody has, or within reason has access to, and it has all the keys and all the sudos and all the passwords and everything is there. So you don't have to reinvent this mechanism every time. And one thing I did that kind of worked great is I put it in a Jenkins job, for example. And if I want to switch over, I just put it in old host, new host, press button, and ran for a couple of seconds, and it was great. So that's good. So failover is just a subset of that. You just, when something fails, you get PagerDuty alerts, and it goes ding, ding, ding. It's like, what did I do? Well, it's only 2 steps, but again, has these problems that do you have the right SSH keys, the sudo is all in that right place. So having a Jenkins job or a script in one place that does everything, that would be great. I'm not going to talk about how to set up automatic failover. That is very dependent on what your requirements are. And a lot of people don't do that, even though they maybe, it would be very beneficial to their reliability and their business. And it's very, very problematic. So unless you really, really need to do it, I would stay away from that. And it really depends on your environment. If you can have like virtual IPs and where can they move and how do you fence things and how is your hardware wired up so you can fence things properly, and it's really tricky. So I'm not going to give you sort of an easy recipe here that works. So if you have done all this, then you need to practice, practice, practice. So switchover becomes not something that's scary, but something that's fun. And that really facilitates a lot of things. First of all, you need to know whether your routines and your scripts actually work. Right? If you never do it, within weeks they rot and it will not work anymore. But it will facilitate so many other things. Like you can easily do operating system fixes, updates, firmware updates, all these things you should do, but maybe don't because you're scared to touch things. If you make this routine and you sort of embrace it, I need to do kernel upgrades. Oh, sure, we'll switch over here, it's great. And you're not attached to your hosts and you're not attached to your old names, and you do this often enough that your application, you know how your application will react, that the application becomes robust to this, that you can do this all the time, and it frees you from being attached to a specific database and a specific host, and if you don't like it anymore, just move it somewhere else. And that sounds sort of maybe optimistic, but that's, I think, a very achievable goal. So that is sort of it. If you think this is all too easy, then here's some bonus reading, perhaps. So Rep Manager is a tool that Second Quadrant is an open source tool that Second Quadrant develops that sort of wraps all this up. I didn't want to make this presentation about promoting our tool, so this is independent of that. But Rep Manager is sort of wraps some of these commands into more easy things. So instead of the base backup, you would just write Rep Manager standby clone. So that's easier, and supports older versions too, and can help with automatic failover, and it can, if you don't have a good configuration management system in place, Rep Manager can help out and make things a little bit more organized. So that's a good thing to look at, but I still recommend sort of learning the basics and figuring out the naming and all those things that you still need to do, especially with Rep Manager, because it requires you to have node names and things like that. So on 2 days ago, when doing the tutorials there, I was not there, but on the schedule there was a tutorial, seamless failover with PG Bouncer and Consul, I believe it was called. And that's something I've looked into myself, and I think it could be nice, but could be a lot more complicated. So you could look into that. For those who don't know at all what that means is that, and Consul and etcd and Zookeeper to some extent are similar products. They're sort of key value stores that are run in a distributed way. So they're kind of databases on their own, but they're very lightweight. And you can store node information in them. And it sort of gets propagated to all the endpoints. And you have agents running on all the endpoints. So what you can do, for example, if you want to do a move of some kind, a switch over of some kind, you just have to change a value in this distributed database and say, this is now the new master. And then all these agents are running on the endpoints, they're informed of that in a timely manner, and then they can run local updates. So for example, you could have in a easy setup, you could have a PG bouncer, a primary and a standby, and they're all connected to this console database. And then you change something, and then the PG bouncer changes its configuration automatically. The master stops automatically. The standby promotes itself automatically, and you can build this out in all kinds of fancy ways. So this is what sort of people are looking into now, I think, is sort of the latest on this. And if this is too boring, we learned yesterday about PG logical. That's logical replication. You can look into that. And if that's also too boring, then you can join the commit fest and review logical replication for Postgres 10. Then hopefully we'll have that in core. So that is my guide to Postgres replication. I hope it sort of guides you in a sort of, or helps you make some decisions based on my experience. So we have 8 minutes for chat. If you have questions or want to tell me that my opinions are wrong, go ahead. Yes, please.
I was curious about archive command. I mean, I certainly know it's a difficult thing to write, but would you say that barman and PG backrest have reasonably solved that problem?
I am not too familiar with the details of these products. So for the microphone, the question was about archive command and whether tools like PG backrest and barman have solved those problems. There are a couple of concerns I have with archive command. One is that basically the new stuff is easier. So why bother with the old stuff? That's sort of point 0, basically. Point 1 is if you set it up in a naive way, you will probably not f-sync the files properly. And it's kind of hard to do this properly. So that I don't know how those tools solve that, but that's a big problem, potentially a big problem for production setup. And maybe not so much for backup setup, but for sort of an actual replication setup. And the third problem is that if you have more than one secondary that you want to communicate to, the setup becomes complicated and error-prone, and you'll have to either have additional hosts that store files, and you have to set up additional permissions to get the right files in the right place, and it's hard to clean them up. So yeah, you can do that, but if you want to do it really right, it's super complicated, and it's not worth it, I think.
Well, if you're going to use receive xlog, though, then you have things going to one place, and you still have difficulty with multiple standbys or secondaries, unless you're going to have multiple streams.
Yes, multiple streams, that's what you would want, because if you have only one stream or one archive command that copies to multiple places and one of those places goes down, what happens to the other place? There's no knowledge in there of how many places you need to really manage. And
it's good if you have the luxury to be able to make that many copies of your wall, though. I mean, there are some people who are just buried in wall. So it may not be the best.
If there are corner cases, there are also cases like if you're sort of running low on space, yeah, then there's some uses for that you can hold on to your wall locally while stream is interrupted, or put the wall on a different host while you fix the other host. So if you're running low on disk space, you can build more complicated systems. But if you're running low on disk space in Postgres, you're never going to be happy. So this is not sort of what I would start with. Question here.
Yeah, I think like most production sites, including ours, they also want periodic full backups and wall file retention that also goes to tape for incrementals. So there's really, I don't completely agree that archive command is difficult to write, but what I have seen from years on the mailing list is guys writing ridiculously overcomplicated shell scripts that look like 8th grade science project that really all it does is copies a file from here to there. And you have to be careful not to have, if you promote a standby, make sure that standby is writing walls to a different repository, because in some cases you'll have a duplicated file. And the segments will be identically named because they came from what is functionally the same replication group, but one of them was half complete and got spit out by the old master. The other one was 100% complete and was produced by the master that just got promoted, and that's the one you actually want to unify with all the rest of the slaves.
Yeah, if you need backups in that sense, which I didn't talk about, and there's obviously a whole world of how you manage your backups, then you do want to have your wall archived somewhere, but I would still recommend using pgreceive xlog to manage that rather than writing an archive command. If you have an archive command and you think it's happy, then don't change it. But I could probably look at it, and I'm not saying what you're doing is wrong, but I have seen so many, and there are so many problems and performance problems and reliability problems and syncing and access control, and it's just all really messy. So it's...
I'm aware of the F-sync problem that came up recently on the mailing list where somebody says, hey, what happens when the box experiences a hard crash? Did the last wall segment actually itself get F-synced? And the answer to that is no, unless you did that inside your script.
Yeah, and that is surprisingly hard to do, that to have an archive command that f-syncs properly on the receiving end, because there's no sort of file system tool that just says f-sync this file. You can obviously write everything yourself or anything yourself to make this work, but it's just for someone who just wants to get it set up. There's other tools that do it well and better. So yeah, I understand this is sort of contentious, but yes, please.
Do you mind if I speak to that for just a second?
Go ahead.
I know some things. The barman is a wrapper around rsync. So the only f-sync you get from it is the one that rsync provides.
Which is none.
Which is not. So barman does not solve the problem. PG Backrest attempts to solve the problem by writing their own C binary that guarantees an exit 0 on fully checks on the copy. The reason for the 8th grade science project is because Wall Archive assumes that if the command that it calls exits with a status 0, that you absolutely did copy the file wherever you said you were going to copy it to. And so all the hoop jumping is basically to not exit in a state where it says it copied, but it didn't. So there's a three-way tie going here, and everybody looks in the documentation and they see this little in the comments. It says, well, you could write your own wall archive command like cp-i, and then you look on the mailing list. It's like, by God, whatever you do, don't use cp-i, right? And so every 3 years there's a discussion that basically starts with, why don't we make this a better example for the trivial case? And then it spirals into, well, because if you only copy it locally, it's only local. So you can use DD or something like that transacts. Now you got a local copy, but it's a local copy. Right now you try to do it over the wire. Well, rsync doesn't give you an f-sync, and nothing else does either. So as soon as you go over the wire, you have the problem that nothing gives you back an exit status 0 when it really has transacted the copy. I had sort of a predecessor presentation to this that I've given a while ago that kind of addresses this in much more detail. So just for the record, for those who are interested, there's sort of 3 ways to actually solve this. One is NFS. The other is that in very recent versions of OpenSSH, the SFTP server has an f-sync option, and then there's also patches for rsync that can f-sync on the receiving end, but that you would have to patch that up. So, but that again, you can do all that. It just seems very complicated. And so, just looking at it from the point of view of a software solution, you've got a 3-way tie where you can't do that until you add some other thing into the loop that actually does provide f-sync across the wire. And that's where PG Backrest is going, is to actually provide a C binary that transacts across the wire and is Postgres friendly.
It's actually not in C, but it does have its own wire level protocol to go and talk to a remote that will f-sync the file and report really no different than PGX log in that sense. You've got binaries on, you've got programs on both sides that are talking to protocol and ensuring success, whereas you can't do that with rsync or, other sort of common tools, which was the whole point to get away from those tools in the first place, because they don't provide the.
So I think the trivial example is solved with PG-based backup and PG receive xlog. And then the more complicated case is solved as
Right, so we're out of time. I'll put these slides online, so hopefully, and there's video, of course. So if you want to follow along, please also see me later if you want to chat more details. Thank you for your attention.